17 and 10. Anything else? Oh, I don't think my computer's plugged in. Ms. Miller, could you maybe check Ms. Zimmer's list of virtual students who are supposed to be virtual today? Yeah. Because I think they said that not everyone who got the memo. They didn't. So you just want to double check kind of this class. Yeah. I can give you. Sorry, guys. There was, if you didn't hear, there was a couple positive cases. So if you're close to those students in class and they don't like announce who those kids are, then you have to go home. So I'm sorry if we end up figuring that out. I don't know.
It's more of our third period.
Yeah. Back there. All right. So in this example, they say the base angle is 37, and then they want us to draw and label the triangle. They tell us isosceles.
Yeah, I'm looking at it.
No, I know. I just don't
want
want
to.
to. I know. Sorry, I should have looked.
No.
All right. So the base angle is 37. They tell us it's an isosceles triangle. Draw and label the triangle. So we're going to draw an isosceles triangle. Now, your drawing does not need to be good. So it's okay if you draw this and you're like, oh no, that doesn't look the way it's supposed to. I mean, if you know how to draw a 37-degree angle, great. If you don't, no big deal. So the base angles, remember, are the equal angles. So those are the 30s, or that's the 37 degrees. But we know that in an isosceles triangle, the base angles are equal, right? So that means the other one is also going to be 37. So again, your drawing might not look like mine, or maybe it doesn't look like the person next to you. It's more that you have all the labels correct. So if those are both 37, what does the other angle have to be? How do we figure that out? What do we know about? Peyton, go ahead.
Yes, the triangle has to equal 180.
Yeah.
So you add the two 37s together and subtract it from 180 and that.
Yeah, so those would be 74. We're going to take that away from 180, and that'll give us our vertex angle. So that ends up giving us that third angle then, and then we have all three. All right, and that's all you had to do with this drawing. Again, you didn't have to like have any other information. Oh, they want to measure the vertex angle, so then that gives us, what is that, 106 then, right? Did my math correctly? All right, then 17. In 17, it says find the values of x and y. And they give you a little right isosceles triangle. So we're okay, good. No one has to leave, yay. That would have been an awkward conversation, sorry. So they tell us it's isosceles because we have the two marks for us, but they also tell us something else about it. What else do we know about it other than the isosceles? Yep. 90-degree angle, so we know this is 90. So if that's 90, how is that going to be helpful for us for the other angles? Yeah. Yeah, and what are we left with then? 90. So we know that these two have to be 90 together, right? But what do you also know about those two angles? Someone want to help Bella out? She's answering all the questions. Yeah, Michael?
They're equal.
They're equal to each other. So if they're equal and they together have to add to 90, what do we know about each of them independently? Yeah, they're 45 degrees. So this is a 45 and a 45. Now later this year, you're gonna see a triangle like this and be like, oh, I know those angles are 45 degrees if you didn't already. So that's something this is a really useful triangle as we work further through the year. We just haven't gotten there yet. So our x is just gonna be 45. And then our 9y is also going to be 45, so in order to find y, I can just divide by 9. So our y ends up being 5. Yep.
Can you do number 20?
Yeah, let's look at 20. So 20. Oh yeah, there's fractions, gosh. I'm sorry.
Trenton Kittler to the middle school office, please. Trenton Kittler to the middle school office, please.
All right, so we have some angles marked here for us. And again, there's a little fraction there. So if you guys, anytime you see a drawing like this and you see kind of like basically like almost like 3 triangles in one and it's really throwing you off, I'd suggest drawing them as separate triangles. So if you're ever like struggling with something that you're like, I can't tell exactly what's going on here, draw it as separate triangles. So this is 50, this is 2y plus 64. So look at just this right now. Let's just focus on this piece of it. That fraction is probably scaring you already, so let's ignore that. All right, so we have an isosceles triangle here. The base angles are equal. Hopefully it's pretty obvious where the base angles would be. Remember the legs point to those. So those two are going to be equal. So a number of different ways you guys can do this. So you know that this is also going to be 2y plus 64 as well. Now setting those two equal to each other is not going to do anything for you. You're just going to get stuck. You're going to end up with like a many solution problem and it's not helpful. So if I know this is 50, kind of going back to the problem we just did a little bit ago, if I know that's 50, how much do I have left over for those two? 130, yep. So we have 130, because 180 minus 50. So these would be 130 together. So each of them then are going to be 65 then, right? So now that I know that, now I can set 2y plus 64 equal to 65. And we end up with a fraction here, so of course we oops, sorry, it should be minus 64. So y ends up being a half. Is that what we got? Yeah. Okay. So y is a half. So now at this point, now you're probably wondering like, well, how does that even help us over here? So in this case, so if I'm looking at this triangle over here, here's our equal parts. This is 45 minus x over 4. We don't know anything about x from that. But hopefully you guys see, does anyone see it? What helps us here? What's that? That straight line, yep. There's a 180 here. We now know that this is 65 degrees. So this is 65. That allows us to find this angle. They form a linear pair, that straight line. So don't forget some of those rules we have from previous sections. We didn't really talk about that at all, but it's so, to forget things, it's okay. Just trying to recall our memory there. So we have to figure out that angle. So 180 minus 65. So I end up with 115, right? for this value here. And then it just becomes a problem like that one, where actually, I realize now we can probably talk about a review topic we're going to talk about here today. So this is 115, so I divide those two in half. So 65 and 65 divided, so 65 divided in half. We get a decimal again, and we have fractions, so we're kind of freaked out by all that. So is it 32.5 then? All right. And so then that gives us this. 45 minus x over 4 equals 32.5. And then we can just solve this. So what do we get here? Now, that -4, just multiply by -4 here to find our x value. Is that okay? Now, this idea here, this drawing, is one of the review topics we're going to talk about today. If you guys recall, that was called an exterior angle theorem that we had talked about in one of the first sections. So it's been a while since we've talked about that, so it's probably a good thing to kind of lead us into our notes for today. Questions? Good questions, because we're all tough ones. So, you guys. So I have this vocab sheet, or this vocab chart for this chapter. Now, hopefully you guys have 4 sheets like this from this year so far. So this should be your 4th chart we made. Not all of them are bright colors like this one. I should have been better about giving you guys bright colors for all of them, but. So this is all our vocab from this chapter that we talked about. So again, this should be your 4th vocab sheet. So this vocab chart will go through all these review ideas that we've talked about from this chapter. Now this chapter had quite a bit in it, and if you guys recall, like I said, I mentioned that exterior angle, that's on here. That might be one you forgot was even in this chapter. I kind of forgot it was in this chapter because it seems kind of disjointed from some of the other things we talked about. So we'll review here today. We'll do this review sheet or this vocab chart. I'm going to give you guys your note card as well today for the exam. To talk a little bit more about the exam here. And at some point during this, we'll get a little break in just so that you're not just writing the whole time. So, our different rules that we learned. So, SSS gave us what? What does that stand for? Side, side, side. It's probably our favorite one. It's probably the easiest one for us to notice. So that means I need 3 sides of the triangle marked as 3 sides of another triangle. So side, side, side is our I'm gonna pull up my old chart here. All right, so one of the things to watch out for, don't forget about like a shared side. So like a picture of this would be, is if I have two triangles, so side, 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 kind of looks like some sort of superhero symbol. So watching out for those shared sides. And not all of these will I have an example for every one of them, so just kind of draw a picture. This is a way to prove triangles are congruent. So all of these listed here, these all prove triangles are congruent. So all of these down to the bad ones prove triangles are congruent. Stopping at HL. There's 5 of them that prove triangles are congruent. Next one, we have what? Side angle side, very good. Now this one is important to note that it has to be the angle between the two sides, you know. So that included angle between those two sides. We see this one a lot with vertical angles. So this one would be example of side angle side. Now that we understand that the S's are side angles, so the next one is angle side angle. And some of these are from when I was gone too, so I know that maybe the review is good here, that we can talk about that. But again, this one is the two angles along the one side. So if I have so this time, it's the side between the two angles we know. Oh, that's not a very good example. Hang on, let me fix that. Actually, other things. This one's angle side angle. The next one is angle, angle side. And this is one that for whatever reason, I think it's just we get it confused with the angle side side rule that doesn't work. So this one's kind of a strange one that it's the non-included side. So if I have two angles, it's the non-included side. Now the one we have to watch out for is HL. What is that one? Hypotenuse leg. Very good. Now, when I say we have to watch out for this one's tricky because it looks like it's an angle side rule. It's not necessarily that. So it's when you watch out for a right triangle. So first of all, it has to be a right triangle, and we know the hypotenuse and one of the legs. So it must be a right triangle. And let me draw. So just remember the hypotenuse is across from the right angle. And then you have to know one of the legs. So again, it kind of looks like an angle side rule, but since it's a right triangle, it's not. It's okay that it just, the hypotenuse and a leg. So this is an example that works. So if it's a right triangle, and we know the hypotenuse, and then we know that leg, that shared leg here, you don't need any more information. Now, I should have put these ones like in bold, like dark letters. These do not work. So these are all ones that do not work for congruence. So do not try to use these. They're bad. Anytime you think I'm writing a bad word that doesn't sound right, like that's okay. That's correct. It's not right. So don't do that. All right. So we use all of these in proofs up to the squiggly line. Then we learned that if we prove triangles are congruent, we can also prove all their parts are congruent. That's when we learned the CP-CTC. So the CP-CTC is used in proofs to prove the parts are congruent. So the first step is we're going to prove the triangles are congruent by one of the ones up here. So we're going to use one of the rules we have. So side angle side, one of those rules to first prove the triangles are congruent. Then we use CP-CTC to prove all the parts are congruent. And that's sides and angles. So in order to use CP-CTC, at some point you got to use one of the ones on the top. You're going to first prove those triangles are congruent, and then you could use those corresponding parts. And you don't need to know what all the words stand for, but we did write it down as corresponding parts of congruent triangles are congruent. Okay. All right, so we talked about the angles of a triangle a lot in this chapter, and that's talking about the fact that the angles of a triangle add up to 180. So if I have my drawing here, angle 1 plus angle 2 plus angle 3 will always equal 180 for every single triangle. Doesn't matter what kind of triangle it is, that will always happen. And I think this section, when we started learning about the angles of a triangle, this is when we were virtual. So this was that 3-day week where we were virtual. So this is something you guys learned online. So it's something that might be a little bit rockier than we'd like. So just be aware of that and making sure that you guys are reminding yourselves of those types of problems. but we use that a lot. The exterior angle one is probably the one that you might have forgotten about. And that's what I was just talking about in number 20, I think, that Drake asked about. So if I have this angle out here, there's a rule that tells us that we can figure out the measure of angle 3 if we know the measure. Actually, I should probably call it, well, is it okay, that's 3, I guess so. So 3 is our exterior angle. So angles 4 and 5 together should equal angle 3. And again, this is something we did when we were virtual, so this might be something that you kind of had forgotten about. And I can show you guys an example of that real quick, just because I'm afraid that you might have kind of forgot this was a thing. Okay, hopefully you have some room on the bottom of your page, maybe. Or if you just want to put numbers with this one. So if I want to do a little example here, so if I'm going to draw it a little bit differently. Look, I can upside down 4 here. So I know this is 20, and this, sorry, that's probably not a very good estimate. Call it 40. And then this is 55. I should be able to find the value of angle x without having to do any extra steps. So it should be pretty fast here. That I can say that these two together will give me that x. And we showed different ways to show this. We could figure out this angle and then figure out x from that. But the idea is that x just equals 40 plus 55. Now again, my drawing's not great, but I want it to be somewhat close. So x would be 95. Now you could go ahead and you could figure out this angle first and then know they add up to 180 together. So that's one of the ones we learned, again, virtually. So you need to go back and look at that at all. All right, so let's flip to the back side. Actually, let's do a quick break here. All right, we'll do some would you rather. Get you guys up and moving, wake up a little bit. All right, turn on the lights too, vampires over there. All right, so, okay, so you're on an airplane. Would you rather get stuck in the cargo hold, so like where the whole luggage is, or have to stay in the restroom the whole time? So you're stuck by the luggage, or you're stuck in the bathroom the whole time?
I mean,
I try to never use the bathroom on an airplane. I don't know about the rest of you guys, but I still think I'd rather not be by the luggage.
I mean,
Yeah, cold. Is the pressure weird down there too? Like, no, is it okay? Oh, it's dogs and stuff right down there, that's right. There was lots of dogs in the airport when I was in the airport last week. All right. Okay, you're living in the wild. You would rather be raised by a pack of wolves or a tribe of gorillas. So you're raised by a pack of wolves or a tribe of gorillas. I know, gorillas would cuddle, I think. I feel like I'd be really clean too. They clean my ears and stuff. All right. Okay. All right, so would you rather be allergic to people or everything but people? So would you be okay with being allergic to people or like animals, dust, everything else over here?
I'm already allergic.
What?
All right.
Neither. I like the team. They are beautiful.
Okay, so would you rather be a zookeeper, work at a zoo? Or would you rather work as like one of the mascots at like Disneyland? So like you're dressed as Mickey Mouse or work with actual animals? Lots of mascots. Do you guys, my brother is a mascot as part of his job. Like that's part of his like, career for the admirals. People always go up to him and be like, we know your sister. That's actually a job. All right. Okay, I don't know why this is a thing. So these are two different things. Would you rather play miniature golf dressed as a sumo wrestler? Or would you rather put socks on your hands and have them talk to everyone you see? So rather than me talking, put socks on. So sumo wrestler, or you have to talk with your sock hands. I think I should do that. Like, 'cause I don't have, like, you can't see my lips move.
They just arrest you just wearing socks.
Okay, next one. I'm hoping that some of you guys move. Would you rather have 10-inch long fingernails or 10-inch long toenails? So your fingernails are 10 inches long or your toenails? How do you guys wear shoes?
All of you want to do is get a bigger size.
I don't need long fingernails. All right.
Toenails got me thick. Or what are you?
Okay, so would you rather wear your jeans backwards, so your jeans are on backwards, or wear your shoes on the wrong feet for a day? So your jeans are backwards for a day, or your shoes on the wrong feet.
Shoes are wrong.
It's like the left foot.
No, see your left.
Okay, so here, let's see what you feel about this. Would you rather have a more beautiful face or a more fit body? Pick one or the other. More beautiful face, more handsome face, or more fit body? We're all too good looking already, right? Like, all right.
That's why I was
Okay, last one here, guys. So all day you have to be handcuffed to the same person. So would you rather be handcuffed to your crush all day, so the person you have a crush on, or someone who makes you laugh? So I have to say both things for me. My crush and he makes me laugh. It's my husband. But, you know, yeah. So both or both. I don't know. All right, you guys can take a seat. I always have to do this disclaimer because a lot of them have my husband, so I have to say good things about him. Otherwise, it's like bad mouth. He's mean. He's not.
One time I tripped and he laughed at me.
Well, that's why you wanted my answer. She wanted to laugh at kids for falling down. I mean, you don't think. People laugh at me for falling down. He's not trying to be mean to you. He likes to laugh a lot. So, all right, so we'll go back to notes here. Thank you for getting up and moving. This is going to tease Will for not getting up and moving. So, not me go. All right, so. All right, so the second half, I wanted to remind you guys of different ways we can prove segments are congruent. So these are different ways we can prove segments are congruent. I don't know if it shows up clearly on here, but these should all be like under this heading to this point. So these are different ways we can prove segments are congruent that we use in a proof. So the first one is a midpoint, is a way to prove segments are congruent. So the way our picture looks So we could say that MB equals MA, and that's by midpoint. So this is our reason over here. This is what the picture would look like. This is what we write in our proof. So this is something we can use in proofs. So this is one of your reasons. Now, if you're really not great at proofs, you guys get a note card for this exam. So put some of these rules down. Like if you won't remember, oh, midpoint, something I can use to prove segments are congruent, then you should write that down. Next one is a segment bisector, which is going to look a lot like the midpoint. Just means it's a line that's intersecting it. So I need to put in a little letter there. So CE equals ED, and that's just a segment bisector. So the difference, a point could be a segment bisector, but typically a segment bisector is like another line, another segment. And then the one we see the most often is called the reflexive property, which is that shared side. And I think you guys have gotten pretty good at this one and noticing this one. So if I have so FG equals itself. And remember, we have to say that in a proof. We have to mention that. And we know it equals itself, and we call that the reflexive property. So those are all different ways that we've used in proofs. The proof segments are congruent. That's how we get our S out of our side, 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 or S out of our side, angle, side. So the way we prove angles are congruent. The one that we probably use most often is our vertical angles. Hopefully at this point we're pretty good at these. So vertical angles, the fact that those are equal, those show up a lot in these. An angle bisector is one that I think a lot of times you guys want to assume is true. Like you'll see it and you'll be like, oh, that's an angle bisector. It has to say it. So it must tell us it's an angle bisector. So let me just show you. So if I have HI, it has to be given to you that HI is an angle bisector. So it can't be something you just say, oh, it looks like one. HI is an angle bisector, so that would mean 3 and 4 are equal. And I'll try to have angles marked as like numbers rather than having used the 3 letters on the exam just to not confuse you too much, to kind of ease it up a little bit. Right angles, we can say that right angles are equal. Oops, why am I drawing it that way? So 5 and 6 would be equal in this case. They're both right angles. Now, when do the next 2 show up? What types of things do we need to, what needs to be true before these 2 will even show up? Yep. 2 parallel lines. So if you don't see parallel lines, these 2 don't even exist, or they don't matter. So remember that if you see parallel lines, these are where you want to, the alternate interior and corresponding angles show up. So the way they typically look in a proof is something like this. I'll show it to you this way. So alternate interior angle would be like angle 7 and 8 here. I should have drawn that here. So 7 and 8. Or the corresponding could look something like this. We had one that kind of looked like, kind of like little double flags here. And that was a tough one, I think. So watch out for those. Alternate interior and corresponding. So when you see parallel lines, it's probably likely I want you guys to use one of those two rules. So kind of just watching out for those keys and kind of being aware. So those are ways to prove angles are congruent. So those are all the different angle rules we have for our proofs. And I'm not giving you guys these huge long proofs that you have to do a ton of different things with them. It's really just like the proofs we've seen in our homework, like maybe like a 4 or 5 step proof is probably as long as we'll get for these triangle ones. And then finally, we talked about isosceles and equilateral triangles. So kind of all the things we know about those. So in isosceles, we know we have 2 equal legs. And then the base angles are equal. So 2 equal legs, the base angles are equal. Then equilateral, all equal legs. And what do we know about the angles? Yep, they're all 60. All right, questions there? Okay, so what I'm going to give you guys now, I'm going to give you guys your note card. So the note card is not really even a note card, it's like half a sheet of card now, so it's big. And the reason for that is I'm not trying to like test you guys on how small you can write. So I make it big intentionally because I've just found over the years that if I make it this small little note card, then somebody can write super, super small and somebody else can't. And then they're trying to like read their note card, like, and it's just causing more issues. So the point of the note card, you guys, the reason why I don't do this for every test is I think you need to study. But I think on a bigger test, I think understanding what I all need to put on a note card like this is a really, really good thing for you guys. So you're like going back and saying, oh, from chapter 1, I won't remember how to name a segment. I need to put that on my note card. Some of you guys are like, I do remember that. I don't need to waste time putting that on my note card. And it's kind of just saying, what do I need to know? What do I already remember? So you guys can use both sides. I will tell you guys, it is unlikely you'll even come close to filling this. So the fact that it's this big is just more of just making you guys feel a little more comfortable and not freaking out over your exam. So you can use both sides of this. Now don't lose this. And now if you lose this one or you want to use one with lined paper, that's fine. I just made it cardstock so it's a little bit easier to find in like your notebook or something. Now it has to be your own, so you can't, like Dawson can't make this awesome note card and then like distribute it to like his friends for $5. So no like making a business off of this.
No.
All right, everyone's got to make their own. And I say all these things because all these things have happened in my years of teaching. So
It's just making profit.
right, I know. I'm trying to have him not be an entrepreneur about his note card. So some things I would put on my note card. Charts like these, things off these charts. So we have 4 charts like these. Now, if you can't find those charts, I believe they're all online, but if they're not, I can post them online. So I can put them on Schoology. So sorry, those of you guys online. Charts. So put the charts on there, your note card. Going through old sections of notes. So like notes from when we review for a test. Like if you go back, kind of the big test review days, those are great days to go back and say, oh, that was a problem that I knew I would have struggled on the test. Like putting an example on there, that's fine. Putting even like a proof on there that you think might be helpful. If you're like, I don't remember even how to write a proof, like put that on your note card. Your note card is not going to save you if you don't know what you're doing. Like it's just not. So if you don't know what you're doing, in the next couple of days, you guys should be coming to see me. So using your AR to come see me, you're welcome to come any day but Wednesday. Because Wednesdays are well, I guess so that really only leaves you today. What's that?
That'd be a little funny. Show up there on Wednesday.
Yeah, I know you can't. Sorry. Trying to break the rules. But yeah, so our Wednesday. But But then also know that that morning time, that optional morning time, you guys are welcome to be in here and asking questions. That's perfectly fine. Don't think that you're gonna come in and if you ask a question, I'm gonna think you're not prepared. You're just asking questions. That's okay. We'll have time to ask questions today and then also tomorrow if you guys are struggling with anything. I would get going on your note card kind of as you're doing your review. So like if you do a problem on your review and you're like, ooh, that's one I might forget, I put that on your note card. Kind of just reminding yourself of what you know and what you don't know. Okay? Question. And some of you guys might not have made a note card before for math, so that's kind of why I'm trying to give you guys some ideas here. Use different colors on here, make it pretty. I don't care, like whatever that you can read it. So people always say, can I use a magnifying glass or whatever? You shouldn't have to write that small. Again, it's big. So don't try to make it like super secret writing or something. All right. So what we're gonna do here, I'm gonna give you guys a little bit bigger chunk of time because I have our exam review packet, which it is a packet. It's like 4 pages. But when you look at it, it's only 33 questions, which isn't terrible. But this, I would really like us to be done with, or this is when we do the exam day. But the more you guys can get done tonight and today, like the more you guys can ask for help on it for tomorrow. Tomorrow is like the last time we're technically together to go over questions. So this is due on your exam day. This is due on your exam day. But you guys have time to work on it now. And so I'm going to tell you guys it'd be a really good idea to be at least to number, I don't know, halfway. So being at least to number 17 by tomorrow would be good. More than that would be better. Here, take that. And if there's anything you're missing or you're like, oh my gosh, I totally don't remember that section, you guys can always shoot me an email and let me know. So I'm glad to send you guys notes from different things, or if you're like, I missed that day altogether. There's obviously videos online for everything. That might be too many. And so, and if you are stuck on something, ask for help now, or put a circle around it and move on if you don't want to stop and try to figure it out right now. Whoops, that's wrong. Sorry, I'm just gonna have you guys write on the top like when our exam is. So like the first couple of questions ask for midpoint and length. So midpoint, there's a formula for that. If you're not gonna remember that formula, I would put that in your note card. Length, what are they asking for? What is the same thing as length in terms of geometry? What formula are they asking you guys to use there? Distance, I heard it. Distance, so when they're talking about the length, they're talking about the distance. So distance formula, do you remember we learned that? So that would be another good note card thing. So our exam is on Thursday. And what time is it at? It's like 9:20. Is that right? I don't want to write the wrong time down. Yeah, it's 9:20, good work. Bella knows. 9:20 to 10:50. But remember that time before that, you guys are welcome to be in here getting help. or just in here working, or in here studying for something else. I have to be here, so I want to be here too. All right, questions? You guys want the time to work then? Okay, so let us know if we can help with anything. Feel free to talk to each other too. Make sure you write down formulas correctly.